Hello and welcome to this film which is all about aldehydes, and it's the second of the films about functional groups that we come across in year 12. So we're going to stick to the same format that we saw in the first film. We're going to start off by looking at the functional group and seeing how it's represented. We're going to name molecules that have an aldehyde functional group. We're going to explain the physical properties of aldehydes, and we're going to look very briefly at the reactions that they take part in, knowing that later on we're going to have a series of films that deals with these reactions in more depth. So here's what an aldehyde looks like. It's got a carbon atom, double bonded to an oxygen and single bonded to a hydrogen. So there's an aldehyde functional group. If I was asked to identify one in a molecule, that's what I'd circle. Okay? If I didn't specify what group was attached over here, so that is if I called it a general R group, then my molecule would have an R, carbon, double bond oxygen, single bond hydrogen. And to differentiate them from alcohols when we're writing their formulas, instead of writing OH at the end, which is what an alcohol would end in, we end the formula in CHO. So anytime a formula ends in CHO, you know you've got an aldehyde present, and you've got one of these types of functional groups. Naming aldehydes is very simple. If you know how to name alcohols, you basically know how to name aldehydes, except that aldehydes end in al instead of ol, like the alcohols did. Okay, so here's an aldehyde. Right, there's the aldehyde functional group. Here's an aldehyde with 2 carbons in it, so it's ethanal. Okay, so ending in al for aldehyde. Here's an aldehyde with 1, 2, 3, 4, 5 carbons in it, so that's pentanal. And you might be thinking to yourself, is it important that I name where this aldehyde group is like it was with alcohols? Well, if you think about it, if I have to have a single bond to hydrogen from my aldehyde carbon, then this chain can't carry on any further. So the aldehyde group has to be at the end of a molecule. In other words, it's always going to be in the same place, so there's no need to identify where it is. Now then, physical properties of aldehydes. Once again, we're going to look at what kind of bonds we've got in this molecule and consider what type of intermolecular forces there'll be. This carbon's going to be slightly positive and that oxygen's going to be slightly negative because there's an electronegativity difference. So there's a polar bond, and so this molecule will have dipole-dipole interactions. Can't hydrogen bond with itself because the hydrogen's not directly attached to a highly electronegative element. So if we were to compare their boiling points with alkanes of similar molecular weight, so similar dispersion forces, we'd expect their boiling points to be higher because of these dipole-dipole forces. But if we were to compare their boiling points with alcohols of similar molecular weight, we'd expect these to have lower boiling points because they can't hydrogen bond with themselves. However, they can hydrogen bond with water, so we might expect an aldehyde to be soluble in water, so long as this non-polar part of the molecule wasn't so big that the insolubility of this part would counteract the solubility of this part. And also, we wouldn't expect them to be quite as soluble as alcohols because the hydrogen of an aldehyde can't be used to hydrogen bond. Okay, so we'd expect them to be soluble and to have higher boiling points than alkanes, but not to be as soluble as alcohols or to have such high boiling points as alcohols. Now, what kind of reactions do aldehydes take part in? Well, we need to know that we can oxidize them and turn them into carboxylic acids. Can actually reduce them and turn them back into the alcohols, but this isn't a reaction that comes up on your course. And as far as making an aldehyde is concerned, you need to know that you can make them by oxidizing primary alcohols. You can't turn a secondary or a tertiary alcohol into an aldehyde, and we'll look at why later on. Okay, so once again, our aim was to know what the functional group looked like, to be able to name molecules with this functional group, and like the alcohols, you don't have to talk about the branched versions. You need to be able to explain the physical properties and know what reactions they take part in. So if there's any questions, or if any of it's a little bit confusing, you want any of it cleared up, please feel free to come and ask, or even better, post a comment on YouTube so that other people can see your question and the answer to it.